Okay, welcome. In this video I'm going to be going through Unit 3 in class worksheet. So let's begin with number 1. We covered number 1 in class already, but I'm going to go through it on the video again just to make sure that you understand each one of these. So it says to identify as a mixture or pure substance. First one is steam boiling off the teapot. This is going to be a pure substance because we are assuming that steam is just water vapor, and that's the only thing coming off the teapot. Anything else would remain in the teapot, would not evaporate. Sand on the beach, that's going to be a mixture. There are lots of things in sand besides just silica, which is the main component of sand, but there are things like seashells and algae and shark's teeth and other things, so that is definitely a mixture. 100% cotton blue jeans, this is a mixture. Cotton is white, blue jeans are blue, so you must consider the fact that there is dye added to the cotton, and that is part of what makes this a mixture. Pure atmospheric air, this sounds like it could be a pure substance, but in fact it is not. It is a mixture. There's lots of things in air. Nitrogen, oxygen, helium, argon. There are aerosols, there are dust particles, all sorts of things that comprise air. Dry ice, pure substance. Again, we're assuming that all of the dry ice is just CO2, and since it is just one component, one compound, and nothing else, then that makes it a pure substance. White gold, this is a mixture. Gold is gold colored. White gold has a different metal added to it in order to make it silver colored. So that makes it a mixture. Deoxygenated blood. This is a mixture as well. There's lots of things in blood. Water, cells, DNA, bacteria potentially, hopefully not, but iron, all sorts of things in blood. Okay. Moving on to number 2. Identify the following compounds as non-polar covalent, polar covalent, or ionic or acid. First one is KCl. K is a metal, Cl is a non-metal, so that makes it ionic. Next one is S8. S is sulfur. Sulfur is a non-metal, and since it is a non-metal bonded with itself, because S is the only thing in this compound, then we call it non-polar covalent. SRO. Strontium is a metal, oxygen a non-metal, that makes it ionic. O2. Again, same thing as with S8. These are oxygen is a non-metal, and since it's bonded with itself, that makes it non-polar. CH4. Both of these are nonmetals. This is a compound, and the carbon-hydrogen bond is a very common nonpolar bond we will discuss in class, so make sure you know that one. Since that's the only bond present here, this is nonpolar compound. H2SO4, because acids begin with H, this is an acid. Same thing for H2S. We say in this class anything that begins with H is an acid, and so H2S is also an acid. Alright, number 3. Predict what the following elements would become if they are ions. Alright, since phosphorus is in group 5, phosphorus will collect 3 electrons to become P3-, at which point it will have an octet. Its original 5 valence electrons plus the 3 makes it an octet. Nitrogen, also in group 5, will gain 3 electrons to become an octet and have 8 total valence electrons. I is in group 7, and I say these technically 17, but 7A, and I is going to gain 1 electron, so it will become I-. Rubidium is in group 1, and so it will lose 1 electron to become Rb+. Strontium is in group 2, so we'll lose 2 electrons to become strontium 2+. All right. Number 4, name the following covalent molecules. Remember that we have to put a prefix in front of the first element if it's not 1. Since this has 2 nitrogens, we need to put a prefix. So we call this one dinitrogen monoxide. Remember that we always put a prefix in front of the second element. Second one, since this is 1, we're not going to put monosulfur, we're just going to call it sulfur. Sulfur hexafluoride. Hexa is the prefix for 6. Next one, sulfur trifluoride, or excuse me, trioxide. Remember that the ending of the second one is always IDE. This one is commonly known as ammonia, but we'll name it according to the rules. Nitrogen trihydride. And then this one here wants us to draw out what the formula would be. Dinitrogen trioxide looks like that. And phosphorus trihydride looks like this. All right, on to page 2. Number 5, predict the molecular formula, name the compound for the following pairs of atoms. Okay, so with this one, Mg is going to become 2+ because it's in group 2. It will lose 2 electrons. Oxygen's in group 6A, so it will gain 2 electrons. This is why these two like to come together. And so we have Mg2+, O2-. If we do our little arrows, we end up with Mg2O2, but we need to reduce that to be just MgO. For the next one, potassium is in group 1, it will lose 1 electron. Nitrogen is in group 5A, so it will gain 3 electrons. Kind of running out of room here, but potassium 1+, nitrogen 3-. Again, we kind of switch our numbers here, our ion numbers, and we get K3N. I'm going to do SiO over here. Si is in group 4A, so it will gain or lose 4. But since it's a metalloid, it will tend to become a cation, so it will lose 4 electrons. Oxygen will lose 2. So let's see what happens here. Si 4+ and O2-. We'll get something that looks like this. We need to reduce this. We can reduce this down to SiO2. We can divide both of these by 2. So that becomes our final answer. With this next one, calcium is in group 2, so it will lose 2 electrons. And then you have the charge of the nitrate because you have to memorize the charge. Switch these two. We end up with calcium with just a 1 down here, an implied 1. And then the nitrate, we need to put in parentheses and then drag that 2 over here. So this will balance out the charge. I guess I didn't go through and name the compounds. This one is magnesium oxide, potassium nitride. This one is silicon dioxide. Well, this one's a little bit tricky. Technically it's an ionic compound, but it's sort of in the middle. It's sort of a gray area. So silicon oxide is fine, or silicon dioxide. It's a little bit confusing because this is a metalloid. It's not a true metal. This one is calcium nitrate. Remember, no prefixes on ionic compounds, with the exception of this one over here. Strontium, again, group 2, 2+. This polyatomic phosphate, you have that ion charge memorized. Gonna trade partners here with the ion numbers. We get SR3 and PO4 in parentheses 2. Remember, we have to use parentheses if there is more than one of a polyatomic ion. So we must use parentheses here. And this is strontium phosphate. NH4 plus and S2 minus. S is in group 6A, so it will lose 2 or gain 2 electrons rather. So we have NH4 needs to be in parentheses because the 2 is going to go with the NH4, and then the S is going to get the 1. So we're not going to put anything at the bottom of the S. Over here, H plus and OH minus. We trade those partners. Then we get HOH or water. This one is ammonium sulfide. Calcium 2 plus, OH minus. Calcium's going to get the 1, OH is going to get the 2. We need to put that in parentheses because it's a polyatomic. And this is calcium hydroxide. Okay, calculate the formula weight for the following compounds. Alright, so we need to look at the periodic table for these. I'm not going to put the periodic table on the video, because I've already looked these up, but just know that this is where we're going to take that number from the periodic table, that average atomic mass. This is where we use that number. So the average atomic mass for sulfur is going to be 32.07. And for chlorine, it is 35.45. I'm going to take the chlorine, multiply it by 6, because there are 6 of them, and then add that to the 32.07. And when I make that addition, I should get 244.77. This is grams per mole. That's the units. For AgNO3, Ag has an average atomic mass of 107.87, N is about 14, and O is about 16. We're not going to round those because they're so close to those whole numbers. Doesn't make much of a difference. There are 3 oxygens here, so I need to multiply this by 3. And then I add all these together, and I get 169.87 grams per mole. For iron hydroxide, iron has 55.85. O, notice how there's a parentheses here, so I need to distribute that 3. So there are 3 oxygens. 16 times 3, and H is about 1 times 3. Add these together, and you should get 106.85 grams per mole. Over here, vanadium oxide. Vanadium comes in at 50.94. Oxygen 16, and there are 4 of them. Add those together and we get 114.94 grams per mole. Calcium phosphate. Calcium comes in at 40.08. There are 3 of them. Don't forget to multiply that by 3. And then P, there are 2 of them. And so that's going to be 30.97 times 2. And then oxygens, this is where people get confused. Oxygens, there are 6 of them. We take the 3 and multiply by 2. So 16 times 6. When we add all this together, should get 278.18 grams per mole. On this one here, we have nitrogens, 14. There are 2 of them. Need to distribute that 2 to this N. There are 4 hydrogens in this ammonium polyatomic ion, but there are 2 ammoniums, so I need to distribute that 4, or the 2 to the 4. So there's 8 hydrogens. Carbon comes in at 12. There's 1 carbon, and then there are 3 oxygens. And then I add all this up together, should get about 96 grams per mole. All right, I think I'm going to stop here and finish out the remaining problems on part 2.